Okay, this is Algebra 2. We're starting a new unit today. We're going to be looking at rational expressions. And something is rational if you have an x in the denominator or the bottom of a fraction. Anywhere, whether you have a plus or a minus or just an x. If there is an x in the bottom, it's rational. So today we're going to be simplifying rational expressions and just kind of breaking them down. So, as I've already said, a rational expression is an algebraic fraction that has polynomials in the numerator and the denominator. In other words, x in the bottom. Keep in mind that a fraction cannot have a zero in the denominator. And this is because a fraction means divide. And we know that you cannot divide by zero. If you have something, you cannot split it into zero parts because you have something. So, if you divided by zero in your calculator, you would get an error. So keep in mind, you cannot have a fraction with a zero in the bottom, which means we're going to have to exclude some values. And so your excluded values are the numbers that cannot be a part of the solution because they would make the denominator zero. So if you looked at number 1 here, all you care about when you're doing your exclude is the bottom. You take the bottom, which is x, and you set it equal to 0, and you solve for x. Well, x is by itself here, so you are going to exclude 0. Whatever you solve and get for this problem, 0 cannot be the solution. So for number 2, you would take your b plus 5, and you would set that equal to 0. You would move your 5 over and subtract it. b is equal to negative 5. So you exclude negative 5. So when you actually solved it, which we will eventually get to, if negative 5 was one of the answer choices, you would mark it out because it cannot be negative 5. Number 3, you're going to say 6 minus c equals 0. Now be careful on this because we have a minus c. You could move your 6 over and subtract it, and so you have negative c is equal to negative 6. You cannot have a negative c, so you change both sides. C is equal to a positive 6, so you exclude 6. It's very important that you understand this exclude situation. So number 1, we're going to factor, we're going to cancel, and we're going to list the excluded values. I want to go ahead and do my excludes and get them over with. If you said x minus 6 equals 0, x minus 6 equals 0, you would get x equals 6. If you said x minus 3 equals 0, you would get x equals 3. So you're going to want to start out by saying you're going to exclude, if you could just read my writing, 6 and 3. Then you want to cancel. In order to cancel, it has to be exactly the same in the top and the bottom. So x minus 3 and x minus 3 are the same. They cancel, and it leaves me x plus 5 over x minus 6. So this is my answer, but don't forget to tell us to exclude 6 and 3. On number 5, at the top, you're good. At the bottom, you have a trinomial. You can't forget how to factor. Okay, you've got to remember these rules. So we're going to find the factors of 3, 1 and 3. Signs are the same. They're all going to be positive, and they have to equal 4. So my a plus 3 on the top stays the same, and the bottom becomes a plus 1 and a plus 3. So my a plus 3s are going to cancel. There's nothing in the top, but you can't leave it empty. So we have a 1 on the top, and we have an a plus 1 on the bottom. So there's your simplify. But don't forget to do your exclude, because you got to answer that part too. Look at the denominator. A plus 1 means you exclude negative 1. And a plus 3 means you exclude negative 3. Because if you said a plus 1 equals 0, you would subtract 1. A plus 3 equals 0, you would subtract 3. So looking at number 6, you need to notice that these are both squares, and the difference of squares means you take the square roots and you add them and you subtract them. So the top actually becomes y minus 2 and y plus 2, and it doesn't matter the order you write it. For the bottom, you're going to find the factors of 2, 1 and 2. Signs are different. The largest one is positive, so the small one is negative, and they have to equal 1. So negative 1 and 2. This becomes y minus 1 and y plus 2. So my y plus 2's cancel, and when I simplify it, I get y minus 2 over y minus 1. Do not try to cancel these y's. You got to think of this as a unit. It's all or nothing as far as canceling. Don't forget to do your exclude. Y minus 1 means we have to exclude positive 1. Y plus 2 means you have to exclude negative 2.
This recording is for Algebra 2.
It's about simplifying rationals. The way that you know you have a rational expression is if you have a fraction that has an x in the denominator. So anytime there's an x anywhere in the bottom of the fraction, it's rational. Okay, thinking back to some things that you already know, you can make equivalent fractions by multiplying both parts by the same thing. So if you did 2 times 20, you would get 40, and if you did 5 times 20, you would get 100. That's legal. You can also simplify fractions by dividing both parts by the same thing. So remember that you can make a change, and it's all legal as long as you make the same change in both places. You can make equivalent rational expressions by multiplying both parts by the same thing. So if you take the top, which was 2, and multiply it by 2x, it's legal as long as you also multiply the bottom, which was x plus 5, times the 2x. You can simplify rational expressions by canceling common factors. Now, before you can cancel, you're probably going to have to factor or break down the top and the bottom. So, we want to simplify, which means we want to cancel anything we can. When you have a plus or a minus, it has to be in every single spot before you can cancel. So you have to look at 8, 4, and 12 on this problem. They all divide by 4. Okay, they all divide by 4. So 8 divided by 4 is 2. 4x divided by 4 is x. Minus 12 divided by 4 is 3. That's your answer. Another way to do it, if it makes you feel better, 8 over 4x minus 12, you can pull out a 4, and it leaves you x minus 3. Your 4 and 8 cancel and leave you a 2. Same answer, different way of getting it. I'd like the first way better, but you can do it either way. You have to look at your 3 and your 6 and your 15. They all have to have something in common. They do. My suggestion on these problems is to start by drawing your fraction sign. 3 divided by 3 is 1. 6 divided by 3 is 2. Don't lose your x. Plus 15 divided by 3 is 5. This is your answer, because each term divided by 3. You can't leave the top of a fraction empty, so you got to put the 1 there. Each of these terms has an x, so you can take one x away from each. So when I take the x away from the 2x, I have 2. X squared becomes x. Bring over your minus. Take it away from the 3x, and you have 3. This canceled with this and with just the squared. This is your answer. You could have also done 2x over, pull out an x, and it leaves you x minus 3. And those x's cancel, and it leaves you 2 over x minus 3. Same thing, just a different way of getting there. My suggestion here is to see what you can pull out. On the top, they both divide by 4, and it leaves you 2x plus 3. On the bottom, when you look at the bottom, these will both divide by 4, so you pull a 4 out, and it leaves you x minus 3. The stuff on the outside can cancel with each other, so our 4's go away. On the inside of the parentheses is protected by those parentheses, so it can only cancel if it is exactly the same. So those 3's can't cancel because they're tied into what was already there. So 2x plus 3 over x minus 3. This is your answer. Okay, so looking at the top, I can pull out a 3, and it leaves me x minus 4. Looking at the bottom, I can pull out an x, and it leaves me x minus 4. The 3 and the x will not cancel, but x minus 4 is exactly the same, top and bottom, so it cancels. And my answer is 3 over x. X plus 5, you can't do anything to. On the bottom, these are both perfect squares, x minus 5 and x plus 5. So think of the x plus 5 on top as having parentheses. It cancels. You can't leave the top of the fraction empty, so we put a 1 there, x minus 5 on the bottom. The top, you can pull a 4 out, and it leaves you x plus 2. The bottom, can't pull anything out, and it's a trinomial. So you're going to want to go to your orange paper. You're going to be using the factor rules that are on the poster on the wall. You're going to find the factors of 12, because 3 times 4
is 12. So 1 and 12, 2 and 6, 3 and 4. Signs are different, and the big one is positive, so the little ones are negative. I need them to equal 4, so it's 6 and negative 2. So bring down my 3x squared minus 2x plus 6x minus 4. Cut it in half. X comes out, leaves you 3x minus 2. Plus 2 comes out, leaves you 3x minus 2. So the bottom is 3x minus 2 and x plus 2. X plus 2 came from what we pulled out. So your x plus 2's cancel, and it leaves you 4 over 3x minus 2. That's your answer. The top, we've got trinomials. The top one you're going to find the factors of 14. 1 and 14, 2 and 7. Signs are different. Large is negative. Need to equal 5. So on the top it's x plus 2 and x minus 7. On the bottom you're finding the factors of 12. 1 and 12, 2 and 6, 3 and 4. Signs are the same. They're all positive, and they need to equal 8. So I'm going to use 2 and 6. X plus 2 and x plus 6. Your x plus 2's cancel, and it leaves you x minus 7 over x plus 6. Okay, on the top one you're going to find the factors of 10 times 10, which is 100. So you've got 1 and 100, 2 and 50, 4 and 25, 5 and 20, 10 and 10. Signs are different. Large one's positive, so the small one must be negative, and they have to equal 21. So you're going to say 10x squared minus 4x plus 25x minus 10. Cut it in half, pull out a 2 and an x, leaves you 5x minus 2, plus pull out a 5, and it leaves you 5x minus 2. So the top is 5x minus 2 and 2x plus 5. On the bottom over here, you're going to find the factors of 100 again, because 25 times 4 is 100. So 1 and 100, 2 and 50, 4 and 25, 5 and 20, 10 and 10. Signs are the same, and they're all negative. And they have to equal negative 20. So it's going to be 25x squared minus 10x plus 4. Cut it in half, pull out a 5x, and it leaves you 5x minus 2. Minus, pull out a 2, leaves you 5x minus 2. So you have 5x minus 2 and 5x minus 2 on this one. 5x minus 2 can cancel, so your answer ends up being 2x plus 5 over 5x minus 2. Okay, a lot of work for that one. That was simplifying rationals. If you have any questions, any problems, come see me during speed.